Good morning, friends. As a part of instrumentation, different types of instrumentation, jobs and studies, right? Today we are going to see about the biomedical instrumentation. As I already know, I have created some two or three videos on biomedical instrumentation because biomedical instrumentation is a very critical field to measure, monitor, and give life support to the patients. Bio-instruments, which helps a doctor to keep patients' health in control and able to monitor the pressure, BP, and we have various parameters. Not only that, say, as already told, actually, when I visited CHAS in Tiruchi. So one person was taken kidney dialysis. In his, I mean, with him actually, he was attached. I can say patient was attached. Actually, saying actually the many biomedical instruments were attached to the patients. So they are taking thousands of readings actually on every second kind of monitoring. Say actually connected to the legs, hand, chest, the stomach, and hips and head, everything. Actually, so we have different types of measurement end to end, top to bottom, right? Actually, from head to foot. So we are taking ECGs, electrocardiograms, and then actually electrotomography, and then actually we are taking CT 700, these things, right? Angiogram. So not only that, whatever I know from, I have forgot all these things, but to my knowledge, actually, it is even actually with the BP pressure monitors, temperature. Actually, to find the fever, right? Actually, we are using thermometers. So everything related to biomedical instrumentation only. So our engineers has to properly calibrate the instrument and make it very sensitive for the changes, patient's health care changes, and everything. So it should indicate the exact position of the body status of the patients. So which helps a doctor. And one more thing I already told, actually, don't check the machine or calibrate the machine when it is connected to the patient's body, because doctors will tell actually due to your machine only we are unable to diagnose a patient in a proper way. So the fault is with you. So actually, if any danger, if any, say for example, due to unforeseen circumstance, if any problem to the patient, then automatically the doctor's trying to throw the ball over the biomedical instrumentation engineer. So the biomedical instrument engineer should be more caution. So if any error, if doctors thinking actually some erroneous value in any biomedical measuring instruments or life care support instruments, then they need to inform doctor to remove that particular default or faulty machines from the patient's body and attach a new one before removing it, right? So then only he need to check. Otherwise, actually, doctors simply throw all the ball to the over the biomedical instrumentation. That again is a big issue, right? It will create an issue. So it is a request from my side that while if any doctors are complaining on your on the equipment status, faulty errors, then ask a doctor to remove that equipment from the patient body, and then only you need to check all these things, right? That is very important. And before again connecting to the patient's body, you need to calibrate the results. Say whatever doctors are asking, checking with the mode of checking, from electronic side, and then actually from the doctor side, what are the health parameters they need to do. So you need to cross check with them. It's a kind of, in SAP we are calling as a user integration testing, right? Like that actually you need to get an UAT from the doctor. First you need to do it is like more or less like SAP, right? Actually, we need to do unit testing. Unit testing in the when you are checking the particular unit, and then you need to give a system integration testing. Means it's a continuous testing. Actually, you need to give a demo of how, if say for example, you need to create a assumption that patient if connected to the equipment connected to the patient. So, what are the health condition, monitor conditions? So, you need to do with some demo kind of say actually any toy or something, and then actually you need to do. I mean, you need to work with the doctors for I can say kind of say UAT or validation testing kind of thing. And then if they are agreeing and they need to sign that this equipment is working properly as per the requirement, as per the expectation, then only with the doctors, after getting doctor signature only, you need to connect the particular biomedical instrumentation to patient's body. Also, doctor's presence is important actually, so they need to connect and you need to assist them. And many, I mean, I heard actually from my professor when I'm doing biomedical instrumentation elective subject, right? Actually, I mean, he's more experienced in that. So he's telling actually normally due to pressure, actually the biomedical instrumentation engineers itself trying to connect due to doctor's pressure. But don't do that. Ask doctor to connect, right? That is the procedure. You are just a engineer, electronics engineer. You never know about medical, even though you are knowing about all this. Medical terms and process, but doctor only knows he's a medical practitioner and professional, so they need to decide. So with that, actually, I like to discuss what are the I mean area of study or scope of biomedical instrumentation. So biomedical instrumentation in any country is good. So other than that, what are the topics? Basically, they are covering. I mean, more than that, actually, I mean, we cannot say that. Just an introduction. So biomedical instrumentation engineer should know electrophysiology, review of physiology and anatomy, resting potential, action potential, propagation of action potential, and bioelectric potentials, then cardiovascular dynamics, electrode theory, and then bipolar electrodes, surface electrodes when connected to the patient's body, and psychological transducers, so which measures the pressures and everything. Transducer is a thing, right? Actually, which converts the pressure to the electric signals. So depends on the variations of heartbeats and everything, impulses. Actually, it will create a electrical signal, right? That is what they are using transducer. So physiological transducers system approach to biological systems, and also he need to know bioelectric potential and cardiovascular measurements, EMG, then actually evoked potential responses, EEG, fetal monitor, EMG for evoked potential response, EEG for fetal monitor, and ECG for phonocardiography, and vector cardiography, BP blood flow, cardiac output, seismography, plethysmography, impedance cardiology, cardiac arrhythmias, pacemakers in hearts, and then defibrillators, right? And then we have respiratory and pulmonary measurements and rehabilitation, physiology of respiratory systems and respiratory rate measurements, oximeter, hearing aids, functional neuromuscular simulation, physiotherapy. So he knows physiotherapy also. The biomedical instrumentation engineer should know the physiotherapy related activities, diathermy, and nerve simulator, and then the patient monitoring systems, intensive cardiac units, besides and central monitoring systems, patients monitoring through biotelemetry. So biotelemetry again is a very good field, right? Actually remote sensing the patient's care, so doctors can get a feedback through biotelemetry of patient's health when connected to the biotelemetry equipments are connected to the patient's monitoring systems, and implanted and transmitters telemetering multiple informations and source of electrical assaults and safety techniques. So actually, when connected to the patient's health, you should not give any electrical assault, electrical shock. So we need to have ensure the proper safety features are monitored and implemented in the patient care monitoring systems when connected to the systems. So there will be proper earth to be maintained. There is no short circuit. All these things when connected, actually the system should be well work, and you should be error prone. If having any error, then it's a great dangerous or a great problem to the patient health, right? So doctors cannot monitor that, and they will simply tell like it is a problem with the biomedical instruments and telemetry instruments. They are not giving proper readings and proper transmitting the signals. This will again the burden to the biomedical engineer. So you need to be more sure before connecting any instrument to the patient monitoring care or anything patient body. So then biomedical engineers should know the recent trends, medical imagining, say optical magnetic recognition, then actually laser applications related, say for eye surgery, cataract surgery, or any say open I mean, as a replacement of open heart surgery, we are using laser surgeries, right? We have a laparoscopy, and now actually it is replaced with the laser applications, laser surgeries and everything. So we are focusing the concentric lasers on the patient body in order to tear that if the knife, actually the laser itself actually will fuse skin, and then it will once the doctor operates, then actually it will stitches the patient's thing. Otherwise, actually later laser beams will be used for diluting or diffusing the tumors and everything, right? So, laser applications, ultrasonic scanners, and echocardiography. So, this is very important for the, for the heart measurements and the heart condition. CT scan, MRI, NMR, magnetic resonance imaging, right? MRI, and cine angiograms, color Doppler systems. Even actually, the Doppler kind of thing, Doppler effect or systems can be used for the patient monitoring system to get the exact sound reflection of the patient body when transmitting toward the sound towards the patient body. How soon it get reflect all these things. So if any tumors or something, it will get that, actually it will get blocked, right? That sound will get blocked. So we can know actually some particle inside it. It's not a normal thing. See, normally actually how the doctors and instrumentation engineer will do that. Say the patient was placed in between this transmitter and receiver. Doppler transmitter and receiver. When sound wave is propagated towards the patient body, how soon it reaches the receiver. So all these things, and say if there any lag or delay in getting things, and then actually the Doppler scan can trace the exact say actually the tumors stop in any star, any block or something, it will, so the signal will get delayed, or the intensity of sound will get the amount of sound or pitch of the sound which was sent with is less, which was received very less in the transmitter side, then actually those are the symptoms for the tumors or some abnormal things, right? So the, and also we are using color Doppler systems and everything. So holder monitoring, endoscopy, all these things. So endoscopy, right? Actually, they were I mean, doctors will send a tube kind of thing with the scanner inside the mouth or in the anus, and take the reading of entire the stomach, digestive system, all this just everything, right? And then you are monitoring in the TV screen. So, if you want to know about the textbook, then Leslie Crowell, Fred J. Wiebel, and Enrich. Yeah, Plifer, Biomedical Instrumentation and Measurements, Prentice Hall of India, 1990. And then I.A. Gettles and I.E. Baker, Principles of Applied Biomedical Instrumentation, John Millie, 1989. So these are the textbooks actually for the biomedical instrumentation. I hope the details I have given is very useful for the those students who are more interested to pursue the career in biomedical instrumentation. Thanks, Prince.